Have you ever considered the power of zero in mathematics? A seemingly simple question, yet it opens the door to a fascinating exploration of the number that is both everything and nothing. Our journey begins thousands of years ago in ancient Sumeria, where zero first appeared as a placeholder in their sexagesimal number system, a role it still plays today. But it wasn't until the mathematicians of ancient India took notice that zero began to truly shine. They recognized it as a number in its own right, giving it the status it deserved. This seemingly small step in fact revolutionized the entire number system, paving the way for the development of algebra and calculus. In the world of mathematics, zero is a paradox. It represents nothingness, absence, the void, yet it's also the foundation of our numerical system. It's the starting point, the line between the positive and negative numbers on the number line. It's the number we add to any other number without changing its value. It's the number we multiply with any other number to get zero itself. It's the number that turns an ordinary number into a powerful exponent. But zero also has its limitations. It's the only number that can't be used as a divisor. Try to divide by zero, and you'll find yourself in the realm of the undefined, a mathematical black hole from which there is no escape. Zero is the hero of the mathematical world, an enigma wrapped in a simple circle. It's the cornerstone of our understanding of the universe, enabling us to calculate everything from the orbits of planets to the behavior of subatomic particles. It's the number that allows us to understand infinity, to grapple with the mysteries of the quantum world, and to explore the vastness of the cosmos. So the next time you see zero, remember it's not merely an absence of value, but a powerful player in the realm of mathematics. What's the magic behind the number pi that has fascinated mathematicians for centuries? Well, let's delve into this seemingly ordinary number that has an extraordinary story. Pi, represented by the Greek letter pi, is a mathematical constant that's integral to our understanding of many mathematical and scientific concepts. It's approximately equal to 3.14, but the beauty of pi lies not in its simplicity, but in its complexity. Pi is an irrational number, meaning it cannot be expressed as a fraction, and its decimal representation never ends or repeats. This makes pi a mathematical marvel. The digits of pi stretch on into infinity, with no discernible pattern, no repetition, no rhythm to its madness. It's like a never-ending symphony, with each digit playing its unique note. This absence of repetition makes pi a conundrum, a puzzle that mathematicians have been trying to solve for centuries. But pi isn't just about perplexing patterns, or rather, the lack thereof. It's about circles. It's the ratio of a circle's circumference to its diameter, a relationship so fundamental that it transcends cultures and centuries. Whether you're rolling a wheel or launching a satellite, pi is there, quietly making sure everything works as it should. Pi also pops up in other surprising places. It's in the equations that describe the spirals of galaxies, the ripples of light waves, and even the oscillations of a pendulum. It's in Einstein's field equations of general relativity, and in Heisenberg's uncertainty principle. It's in the statistics that predict population growth, and in the algorithms that power our computers. In essence, pi is a mathematical superstar. It's a number that's so much more than just a number. It's a symbol of the inherent beauty and complexity of mathematics. It's a testament to the fact that sometimes, the simplest things can hold the deepest mysteries. Whether you're calculating the circumference of a circle, or exploring the mysteries of the universe, pi is there, a constant companion in our mathematical journey. What if I told you a sequence of numbers could predict the patterns of nature? Now that's a thought to ponder upon, isn't it? Welcome to the fascinating world of the Fibonacci sequence. This sequence is as simple as it is mysterious. It starts with 0 and 1. Each subsequent number is the sum of the previous two. So it goes 0, 1, 1, 2, 3, 5, 8, 13 and so on. The beauty of this sequence lies not only in its simplicity, but also in its unique properties. One such property is that the ratio of two consecutive Fibonacci numbers approximates the golden ratio, an irrational number roughly equal to 1.618. The golden ratio is believed to be the most aesthetically pleasing proportion to the human eye. But the magic of the Fibonacci sequence doesn't stop at aesthetics. It extends its influence to the very patterns of nature. Take a look at the arrangement of leaves on a stem. It's often the case that the number of leaves per turn around the stem is a Fibonacci number. This arrangement allows each leaf to get the maximum possible sunlight, a survival advantage in the wild. The Fibonacci sequence also makes a surprising appearance in the pattern of a pineapple's skin. The number of spirals in either direction on a pineapple are consecutive Fibonacci numbers. Isn't that remarkable? And the Fibonacci sequence doesn't limit its magic to the Earth alone. Even the shape of galaxies, the grandest structures in the universe, display a logarithmic spiral that can be described using Fibonacci numbers. So there you have it. A sequence of numbers, as simple as adding the previous two, predicting patterns in nature from the leaves on a tree to the spirals of a galaxy. It's a testament to the harmonious relationship between mathematics and the natural world. From the smallest flowers to the grandest galaxies, the Fibonacci sequence is nature's favorite math. Can you imagine a hotel with an infinite number of rooms, yet always has room for more guests? Quite a bizarre thought, isn't it? But welcome to the world of infinity, where things can get a little, well, infinite. The concept of infinity is a fascinating one. It's a number, but it's not really a number. It's more like an idea, a concept that represents something without any limit. When we say something is infinite, we mean it has no end. It goes on forever. And that's where things start to get tricky and paradoxical. Let's take a step into the realm of infinity with a thought experiment known as Hilbert's Hotel, named after the German mathematician David Hilbert. Picture a hotel with an infinite number of rooms. Now suppose every room in the hotel is occupied. A new guest arrives and asks for a room. Impossible, right? After all, every room is already full. But hold on, this is no ordinary hotel, this is Hilbert's Hotel, a place where the impossible becomes possible. The hotel manager has a clever solution. He asks each guest to move to the room number that is one higher than their current room. The guest in room 1 moves to room 2, the guest in room 2 moves to room 3, and so on. Now, every guest still has a room, but room 1 is suddenly vacant, ready for the new guest. Despite the hotel being full initially, it still managed to accommodate an extra guest. This is the paradox of infinity. It defies our usual understanding of numbers and space. Infinity is not just a mathematical curiosity. It has profound implications in physics, cosmology, and philosophy. It challenges our understanding of the universe and our place in it. It reminds us that reality can be far stranger than we can possibly imagine. Infinity, a concept so vast and mind-boggling, it challenges our understanding of the universe. So next time you think about infinity, remember Hilbert's Hotel, and let your mind wander into the endless corridors of the infinite. So, what mind-blowing math facts have we unearthed today? A question that has been ringing in our minds as we journeyed through the mesmerizing world of mathematics. Let's take a moment to reflect on the power of zero. It's a concept so fundamental yet so profound. Zero, a symbol of nothingness, has the power to transform a number, to shift its value. It's not just an absence, it's a presence that makes a world of difference. Then we delved into the magic of pi, a number that is as infinite as the universe itself. Pi, a constant in a world of variables, has been a cornerstone in the understanding of circles and spheres, and continues to baffle us with its endless, non-repeating decimal expansion. We also unraveled the mysteries of the Fibonacci sequence, a sequence so simple, yet it's found in the most complex of natural phenomena, from the petals of a flower to the spirals of a galaxy. It's a pattern that nature seems to love, a pattern that we humans find aesthetically pleasing. And who can forget the paradox of infinity? Is it a number, is it a concept, or is it a state of being? Infinity, the idea of something without an end, challenges our understanding of the finite world we live in. It's a concept so vast, it often leaves us in a state of awe and wonder. Each of these concepts, the power of zero, the magic of pi, the Fibonacci sequence, and the paradox of infinity, continue to fascinate and challenge mathematicians. They inspire us to push the boundaries of our understanding, to question, and to explore. These math facts are not just about numbers and equations. They are about understanding the patterns, the constants, the variables, and the infinite possibilities that the universe presents to us. They are about discovering the language of the universe. Mathematics, it's not just about numbers and equations, it's about understanding the language of the universe. The power of numbers indeed.